I've been around digital oil field for about 20 years now, and it used to be called the digital oil field of the future, and then lots of people had their own version of it, E-field, I-field, field of the future, and then it became intelligent operations, but it was really the same thing, but rebadged. And there's a danger now that digitalization, people might be getting stale and going, oh, well, we've been talking about this for years. But I think it is different now because there is a lot of stuff available off the shelf now. Actually, the technology, the Lego box that you can pick from is much, much bigger than it's ever been now. And also we're seeing a lot of the stuff now in everyday life. This is no longer totally cutting edge, that the stuff you're doing in work has never been seen at home. Actually, now consumers technology's moved on and it's kind of expected. So I really think we could deliver it now. We could get that dream of fully integrated data, save money, efficient systems.
I agree, and I think I just carrying on from the digital twin conversation, because I see robotics as part of the digital, right? And it's about the approach. It's if and this is a frame we've used within the team. And it's more about approach and making sure that we're debating it, right? And it's just a simple picture, but it's about workflow, right? Is actually completing this workflow versus perfection in any given piece of that workflow, right? And from a digital twin standpoint, it materializes as I need to get all of my data structured properly and accessible. And once I do that, then I'll work on actually doing something with it, right? And then once I do that, then the path to value is pretty far out. It's that $1 million that I'm constantly running after, and stepping over everything else. Eventually, maybe you get to it, but in the cycle time of projects and the cycle time of budgeting and reorganizations, therefore opinions, many projects like that never make their way to the end. Right? You've completed that, but you never got to this, or you got 3/4 of the way through that and they didn't see any value, so we cut it, right? No more. And the reason we looked at that frame with the team was it was really to debate how far are we? Are we good enough? And making sure that we're actually working across that entire workflow. If I want if I want to basically create a recommendation machine for compressor anomalies, I don't need to get all of my separator pressures, temperatures necessarily, structure, all that data structure. I need to get all the relevant compressor data structured. Now, some may say, well, but all of that data is relevant. You're right. It's probably tertiary at best, right? I can get 80%. This data is good enough to then move on to, now I need to flag anomalies from that data. Look what baselines look like and identify, okay, that third step is now I need to get all the relevant compressor design data in, get my cause and effects in, get my maintenance data on those compressors. Not all the maintenance data, compressor maintenance data. And then I can start cobbling together using rules and logic, right? Something that recommends based on an anomaly what I should do, what it could be, and what I should do based on that. I see robotics is very similar, right? If we wait for, and here's a good example, an ATEX certified, intrinsically safe robot to even put a robot out at our sites, we're going to be waiting a long time, waiting for the perfect robot, which may come, and there are some out there, is not going to get you ahead. You're better off, in my opinion, taking what you've got and then starting to overlay, as we said before, now go get me data, right? Make sure I can hook a sensor to it and it feeds back to me. Now let me make sure I can process that data and do something with it, identify anomalies, and then, continue and continue. Waiting for it all to come together before I ever put a robot onto a site, you're missing out on a lot of learnings, right? I mean, it's optimizing the components is not going to lead to an optimized outcome.
No, that's completely right. And how is it going to come together unless someone does it? what you're really saying is, well, we'll do nothing and we'll watch everyone else do it and then hope we can jump in at the end and catch up. And it doesn't work like that. And we're in danger of preaching to the choir here, because having been through so many projects where these aren't well-known projects, a lot of the times it's the first time something's being done. It's extremely difficult, and in fact, it's impossible to accurately define the extent of it up front. So to the classic question, well, surely you can tell me how long it's going to take and how much it's going to cost. The honest answer is not really. It's actually very complicated. The only way we'll know exactly what needs to be done is to have done it once. And so rather than sitting in a room and trying to theorize, you're far better just getting out there and figuring it out, because for sure there'll be stuff that comes up that you never thought of in the room, but also what turns out to be the really difficult stuff is not what you expect either, like the Daleks going upstairs or something. It'll be something apparently simple that you suddenly realize is extremely difficult to deal with in practice, and you just got to get going. Yeah, I completely agree.
Yeah, and yeah, I mean, look, there's all kinds of futuristic scenarios we can have, right? Oh, well, I don't need a robot that can climb stairs. I will have a robot that can deploy a small drone to go do that inspection for me when it runs across it. That's great. But to be honest, I mean, if we're working towards a robot that can deploy its own drone and then communicate and get that information back to it, that's great. But if you don't have a robot that's taking care of the rest of the 95% of your site, then that effort, in my opinion, is a bit too early, right? Get the value from the robot now. Your focus should be on getting what you can do today, getting the value from that. And, and I think, I can't speak for everyone. And I think the different companies are in different spaces, but I think that's a key thing that needs to change in general, is getting these things out there that are good enough. The robot technologies out there are good enough. Could they be better? Absolutely. How are they going to get better fastest? By using them and actually having real feedback loops on how to modify the designs or some of the software on it. But theoretical loops aren't necessarily leading to a better outcome or a better machine. So I agree.
Yeah, great point. Maybe others will disagree, and I'd love to hear from you if you disagree, and it would add spice to the debate, because I'm sure there's a viewpoint, and certainly for safety things. Although you had a very interesting point about inspecting a flare stack. Actually, a robot's a perfect candidate, because you don't have to isolate all the safety systems. If you're inspecting it and the flare happens to go off, you just have to write off a robot. But it's still cheaper than shutting down production in order to have a human do it.
Absolutely, especially when you look at how many isolations you'd be making. That can be, depending on the size of the facility, that could be a week's worth of work just doing those isolations, and the de-isolations that follow. And back to the statistics conversation, if error happens at some frequency, the more you do it, the more likely you're going to have an error. So are all those isolations in place? Are they all now, free to flow in the event of a safety incident to your flare header? Or did we miss one, right? We did 1,000 of these things. And that adds to that time, right? Which is why it takes so long. It's not just around jumping around, flipping valves.
Yeah.
So